Good morning, everyone. My name is Greg Aranda with Graybar. I'd like to welcome you to Graybar's G2 Talk presentation this morning called Improving Electrical Safety Compliance, Arc Flash and Lockout Tagout. This talk is part of a webinar series we offer each month for our customers. We have a great discussion lined up for you today, but before we get started, I'd like to cover a few housekeeping items. First of all, if you are one of the first 50 people who join this presentation, you'll receive a coupon for a free cup of coffee, courtesy of Graybar, as a thank you for your time today. Also, on the bottom of your screen, you'll see a box for Q&A. Feel free to submit questions throughout the presentation, and we'll address as many questions as time permits at the end. Lastly, our G2 Talk webinars are all archived on graybar.com. You'll be able to view this presentation again or recommend it to others. Today, we're happy to team up with Brady. As an electrical distributor, Graybar works alongside Brady to provide customers with a wide range of products to keep workers safe and facilities up and running. At this time, I'm pleased to introduce today's speakers, Andy Mueller and Josh Mikels, who are both in the Safety and Services group at Brady. Andy has a Master's of Science in Occupational Safety, Health, and Environmental Management and has more than 15 years of experience as a safety professional leading the implementation of safety management programs. Josh is Brady's solutions owner for Arc Flash. He is a licensed electrical engineer and has more than 12 years of experience in electrical safety and project management. So without further delay, I'd like to turn it over to Andy. Take it away, Andy.
Thank you very much. Thank you, Greg. And good morning to everyone. Thank you for taking time out of your busy schedule to attend. Going to go right into it. So our discussion is on Arc Flash and Lockout Tagout. I'm going to be covering the Lockout Tagout section first, and Josh will be going into the Arc Flash training after I complete the Lockout Tagout section. So to start out, where does Lockout Tagout come from? And I'm sure this is not new for anyone, but it comes from OSHA, and that's the specific regulation that you should see on your screen, documenting that procedures shall be developed. Just a little bit of history on OSHA's top 10 list. OSHA on the top 10 list, Lockout Tagout has been in the top 5, 7 of the last 10 years. It was 5th on the list last year, and in 2003 was the last time it was actually number 1. And for, I think, as long as they've been doing the top 10 list, Lockout Tagout has been there. That's how important it is. So some of the problems that come up, the top on the list is inaccurate procedures or procedures that are out of date or various things associated with the procedures, and then maintaining those procedures is usually the top item when it comes to people who have implemented Lockout Tagout programs. Some of the common areas for improvement, misuse of generic procedures. I'll just write a procedure, some companies will, that just have a list of electrical, gas, pneumatic, check all these to make sure, without any clear instructions. Procedures that are out of date, that haven't been audited, energy sources that are omitted, overly complicated so operators don't even use them, don't even read them, and then it's hard to update them. Not readily available. The most important people that should have those procedures are the operators themselves or the mechanics that are doing the work on it, especially those that are authorized Lockout Tagout people. Lack of verification steps. Outside of not actually doing Lockout Tagout, the verification step is important because most people don't verify to check that what they shut off is actually turned off. And then someone's working on a piece of equipment, someone's pitched the start button or inadvertently starts and they get injured. And then not listing Lockout Tagout devices. How do you specifically lock something out, especially with something that doesn't accept a lock, a tag, or a hash directly? So to improve your creation process, the first and foremost thing that we ask for when we are doing procedures is to start with an accurate machine inventory, because you want to make sure you capture all the machines that should have Lockout Tagout procedures. The next is getting the right people involved, mechanics, operators. We call them subject matter experts, those people that would know the hazards of the machine, understand the operation of the machine, address real-world tasks. We can't solve the 1 in a million just in case it might potentially happen because the procedures would become too inundating. It's solving things for things that happen on a day-to-day basis and looking forward to any potential hazards to prevent them from happening, and then verifying them for accuracy. The most important part is accuracy. If I wrote a procedure and put down the wrong electrical disconnect switch, somebody's going to turn off the wrong electrical disconnect switch, and hopefully they're verifying, but if they don't verify, they just assume that it's correct. So the most important part is to verify for accuracy. So short-term wins. So depending on the size of a facility, if you have 200 procedures, much easier than if you have a facility that has 1,400 or a couple thousand procedures. So the biggest question is, where do I start? So phase one, just some suggestions. Start with all equipment in a small area. Start with similar equipment in one facility. If you're writing the procedures, you have someone else come in and write the procedures. It's an easy way to simplistically set the format, the content, the language that's within the procedure, have it reviewed by operators, and then move into the more complicated things. Then go into all equipment everywhere. Don't bite off too much because it can become inundating. Put a 3-month or 4-month or 6-month plan together on what it's going to look like in 3 to 4 or 6 months. And then get into the complex high-risk equipment and determine, okay, where do I go from here? Because it's a difficult place to start at the complex high-risk equipment. You'll find yourself editing and changing procedures quite often as you go through and write procedures. So the Brady procedure, the solution that we provide, you can see an example of one of them on the screen. Just a quick scenario of some of the sections that are there. The top is general information, typically taken from the machine inventory section. It includes an asset number so that it links into a system that you may already have for machine management, for preventive maintenance or any other maintenance function, a title of the machine, a location of where it's at, and then it goes into special hazard notes and lockout points. So when there's energy sources that are entered in there, it accumulates them to count the lockout points. And then there's a note section. Some customers change it to a caution section. Something not necessarily related to lockout tagout, but has some unique hazards specific to that machine that the person doing the work would want to know about. Some of the application steps and even the application steps process section. What's the steps for applying a lock? In summary, right on the front page so that people remember to follow the steps in order because they're important. The next section is photos, equipment photos with energy labels. The easiest way for an operator to ensure they have the right one is to compare it to a picture, which leads down to the next section, which is where we start listing the energy sources. It provides the method to isolate it, the devices required, the method for verification, and in some cases, lockout removal steps if there's something extra that has to be done for lockout removal. And then the key part of the lockout tagout is the E1, or the labeled energy source, actually matches a tag that hangs right on the energy source. So not only do you have the picture, you have the identification of the energy source and a matching tag that goes right along with it, so that there's multiple verification steps to make sure that it's the correct isolation point when they're turning the machine off. On the back side of the procedure is all of the other elements. So the purpose, scope, and enforcement, basically for them to understand what's the purpose of lockout tagout, what it covers, and what happens when you don't follow it. The next section is a description of the application steps. First and foremost, and when we go out and do training, and then we do a hands-on for authorized employees, one of the first questions we ask is, what's the first step? And most people say, well, I got to go identify the energy sources. We say, stop. What's the first step? And then we have them flip the procedure over. Oh, yeah, tell the employees. The biggest and often most missed item is the notifying and communication steps. And then as you move down, I'm getting ready to restore it to service. What are the descriptions of the removal steps? Again, with communication, testing functions, make sure a machine is put back into manual and ensure that the machine isn't going to automatically start up as soon as I turn on an energy source or engage something as soon as an energy source is engaged. The next part of the process is then identifying proper devices. And Brady has hundreds, I don't know the exact count, but hundreds of different devices you can purchase. 3 specific categories: electrical, valve, cable, or really any type of device to lock out a point if there doesn't accept a lock for some reason. Group lockbox or hasp, or things when you have multiple people, contractors, working on the same project. Instead of handing someone 15 or 20 locks each, they're grouped in a box. You drop the keys in, people put their locks on the box and remove them as they go on and off the project, with a project manager putting their lock right on the end of the box itself. They're documented on the procedures. It's a great idea to keep an inventory and keep on hand as many as you think is necessary. Otherwise, they tend to get lost, and if they're lost, people tend to not then follow the procedure or take shortcuts in regards to lockout tagout. Make them available near the point of use or in another clearly marked location if possible, but always make sure they return there. Similar to a 5S process, running around and looking for tools is not an effective use of time. And then the last part of the lockout tagout is periodic inspections, the sustainability piece. It is a requirement that those procedures are audited at least annually. Even if changes aren't made, it isn't an effort to update every single one. As you can see on the graph below, this is kind of standard safety management. Something happens, we become compliant. Then we drop off, something happens, jumps us back up, and we change something. If you do compliance and then have sustainable change, you can see that you'd be above the compliance line because you're maintaining things from a proactive standpoint. With that, please make sure if you have any questions, enter them in the Q&A session, like hitting on the Q&A on your screen. And I'm going to turn it over to Josh Mikels, and he is going to talk about ArcFlash.
Thanks, Andy. Appreciate the introduction, and also appreciate all the information on lockout tagout. Good stuff to know. At this point, as Andy said, I'm going to switch over and talk to you a little bit what you need to know about ArcFlash and what actions you should be taking now to ensure that the other half of your electrical safety program, the ArcFlash side, is up to date and you're in compliance. When talking about compliance and complying with the updates, it really isn't just about the updates. That's not all you need to be concerned about. In many cases, it's about ArcFlash compliance in general. The codes, that regulate this, NFPA 70E, is updated on a 3-year code cycle. The current version is the 2015. If you happen to have a copy of that, a hard copy, you can see all the modifications that are made. They're highlighted with kind of a gray highlight in the book, so they make it very clear what changed from previous years. When you're talking about 70E, it's really important to also touch on OSHA and the National Electric Code, NFPA 70. A lot of people that I run into will say, well, NFPA 70E isn't a law. They say, we don't have to do this stuff because it's not a code. In a certain way, that's accurate. NFPA 70E is not law, but it is a recognized industry practice, also known as a consensus standard. OSHA is law and National Electric Code is law, and they both require that you take steps to make sure your employees are safe. They talk about PPE, they talk about training, and they talk about the labels. OSHA and the National Electric Code both recognize NFPA 70E, and they also specifically reference 70E as a way to achieve ArcFlash compliance. So it's really important to kind of understand how those relate and understand that 70E is the best way to achieve compliance and make sure that your employees are safe. When you talk about NFPA 70E, as you can see there on the screen, FIDOT says the ArcFlash risk assessment shall be performed and you shall determine what those hazards are. So this is the driving force behind ArcFlash compliance. Some of the major changes that took place in 2015 are listed on the screen. One of the first ones I kind of like to touch on is a very simple and subtle one, but it's important. In the previous versions of NFPA 70E, talked about ArcFlash, talked about doing a hazard analysis. Now they refer to this as a risk assessment. It's a very subtle change in verbiage, but it's important to note because a hazard is just a source of possible injury. If you look at the definition in the code of a risk, there's a combination or a likelihood of occurrence there. So what the authors of 7E are really trying to do there is drive home the point that, hey, this is not just a hazard, not something that might happen. There is definitely a risk there, and it's something that needs to be addressed. So the authors of the code are starting to drive the point that this is something that truly needs to be addressed. And, you know, when you start looking at OSHA fines in that top 10 list that Andy mentioned, the electrical items related to arc flash are starting to creep up on that top 10, and they're becoming more prevalent. One of the next major changes that took place is in reference to the new PPE category tables. Everyone's very familiar with the HRC, hazard risk categories, and that's what used to be in 70E as far as being called the table method. People could go in there and you look at the different categories, 0 through 4, and people would say, I have my Cat 1 PPE, I have my Cat 2. The tables have been completely rearranged, and now there's two sets. The first table is task-oriented, and it looks at various tasks and says whether you need to or whether you do not need to wear PPE. Once you've established that, then you go to the second set of tables that then defines your PPE category, whether that's 1 through 4. To note, as part of that, they also eliminated HRC 0. HRC 0 was essentially removed because anytime you're outside the arc flash boundary, it's less than 1.2 calories per centimeter squared, and that was HRC 0. So in effect, even though they dropped out that actual category of 0, people still need to wear the general PPE. If you're at 1.2, you still need to be protected wearing your non-melting all-natural fibers, but they just dropped out that category. Similar to that, if you look at prohibited approach boundaries, they also removed that terminology. There used to be 3 approach boundaries. Prohibited was at 1 inch. The other 2 approach boundaries, the limited and restricted, those drove some type of action on the user. Qualified people understood this, and as you approach the panel, those 2 boundaries, they made you do something. You couldn't allow unqualified people within, or you had to have your PPE on. The prohibited approach at 1 inch didn't cause any actions, so the authors of the code decided to get rid of that because it was causing some confusion. Next major change when they start talking about qualified persons. The big push there is, a qualified person had to have someone that they had training and they had the knowledge on what was there, but now the code really focuses on the fact that these people have to be able to demonstrate the skills. It's not just enough to have the knowledge, you also have to be able to demonstrate that you know what you're doing as part of your work and making sure that you're safe around arc flash risks. And the last major change that I like to touch on is the updated label requirements, and we'll get into that here in a slide in a couple minutes. Before talking about what's on the new labels, it's important to talk about what needs to be labeled. NFPA 70E and the National Electric Code both use fairly vague verbiage. When you look at the code, they say equipment such as switchboards, panel boards, industrial control panels, meter sockets, and MCCs shall have these warning labels on it that tell people what the hazards are. That vague terminology, allows for some interpretation, and some people start to wonder, well, what actually needs to be labeled? But what's important to note is that both of those codes do focus on a 50-volt number, and OSHA talks about this 50-volt number as well. Anything over 50 volts that has the likelihood to be worked on while energized, and worked on, they talk about troubleshooting, maintenance, a lot of different things. So pretty much anything you're going to approach and be exposed to while energized over 50 volts should have a label. So a lot of times, disconnect switches. Disconnect switches are a very common piece of equipment that's not specifically listed in the code, but that's something that often is opened up, exposed, so people are exposed to while energized. And you do testing or troubleshooting at that disconnect switch, and that is a arc flash risk and should be labeled. Moving on to a little bit talking more about, what actually should be on those labels. 2009, when you look at the national, or you look at NFPA 70E going back then, simply said that electrical equipment had to be labeled with the available incident energy or the required level of PPE. That vague definition led to some confusion. So as as the code moved forward in 2012 and now in 2015, it got more specific and actually started to list out what needed to be on those labels. The information there on the screen is an excerpt from NFPA 70E and shows what needs to be on there. Nominal voltage is pretty straightforward. Is your panel 240 volts, 208 volts, 480 volts? What's the nominal voltage of that equipment you're putting the label on? The arc flash boundary is also required. What the arc flash boundary is the distance at which the incident energy is 1.2 calories per centimeter squared. So that arc flash boundary is going to be directly related to how severe that explosion is going to be. The greater the explosion, the more distance that explosion is going to travel out of that piece of equipment. And at some point, it dissipates and gets down to a level of 1.2 calories per centimeter squared, and that's where that arc flash boundary is defined. People outside that arc flash boundary, are still potentially going to be exposed to some sort of, incident energy, but the levels at that distance or that level of incident energy are going to cause something less severe than a second-degree burn, so it's not a high level of risk. The code then goes on to say at least one of the following. It talks about available incident energy and working distance, or arc flash PPE, minimum arc rating of clothing, or the site-specific level of PPE. What I like to draw attention to here is that first one, the available incident energy and corresponding working distance, or arc flash PPE category. The available incident energy is what we just talked about. That's that 1.2 calories per centimeter squared, 4.8 calories. Could be anywhere. I've seen them up in the hundreds of calories per centimeter square at main switchboards. And that is always calculated right at that working distance, which is going to be 18 inches. 18 inches is the working distance that code defines. Key to note there, it says or the arc flash PPE category. If you look at pretty much every label out there prior to 2015, you would see the incident energy and a working distance, and you would also see an HRC category, that 0, 1, 2, 3, or 4. The authors of the code realize that, a lot of times those are both on there, and sometimes those can be conflicting in certain ways, but really the point is those two pieces of information are derived from two very different methods of calculation or of methods of arriving at that data. That available incident energy at the working distance, at 18 inches, that data is calculated based on the incident energy analysis method, which, that's having a consultant come out to the field, gather a bunch of data, and use software programs to do some calculations and figure out what that information is. That PPE category, or what used to be called the HRC category, that's using the tables in NFPA 70E to look at, what's my situation, what's my equipment, what am I doing, and coming up with that 0, 1, 2, 3, or 4, which, as we talked about earlier, is now just 1, 2, 3, or 4. So when you look at labels, if you're having someone coming out to do an energy analysis, you shouldn't have that 1, 2, 3, or 4 on the label. You should just match it up with whatever that incident energy is. And some people are a little confused by that, but it's really quite simple. If the label says your calorie level is 3.2, the people working on that panel have to wear something greater than 3.2 calories per centimeter squared. So in this case, you would, at a minimum, wear a 4-cal shirt and pants and the rest of the PPE. When you look at these labels, that's what's required, that's what's listed there, but you can also put additional information on there. So oftentimes a best practice label is going to include, what's the equipment name? And it's also going to include data such as, what's the upstream overcurrent protective device that's feeding it. So, this kind of ties into Lockout, tagout, and you've got the name and information on there, and also shows you where it's fed from. So potentially if you want to shut this down, if you don't have that Lockout, tagout stuff handy, you know where to go back to turn off power. So moving on, it's always important to make sure that your arc flash risk assessment is up to date. What NFPA 70E says is that anytime a major modification or renovation is done, you've got to update your arc flash risk assessment. So, if you do a major addition, that's pretty straightforward. You're going to be adding new equipment. They're not going to have labels. You've got to have that taken care of. But, over the course of time, facilities make a lot of little changes. So what the code defines is they say, you have to update or essentially audit your arc flash risk assessment at intervals not to exceed 5 years. So over the course of that 5 years, you might move a piece of equipment to the other side of the room. You might add 1 or 2 pieces of equipment. You might delete a couple pieces. And, it's really important to understand that if you simply move a piece of equipment from one side of the room to the other, that label that was on the piece of equipment before is no longer accurate. That change in distance alters the calculations, which is going to potentially change the incident energy levels at that piece of equipment. So, it's important to understand that very minor changes to your electrical system can impact the incident energy level at your equipment. As we said before, it's also very important to remember that all locations where voltage is greater than 50 volts, those are the things that need to be labeled. So I've been to a lot of facilities where, they might have panel boards, motor control centers labeled, but they miss a lot of disconnect switches or industrial control panels, which in many cases the control panels are things that get opened up and the troubleshooting activities happen there quite more frequently than they would at a panel board. So there is a lot of risk at anything 480 volt, 208, 240, and those things should be included in the assessment. Another question I often get is, when is the table method acceptable? Do I have to have an engineer come in and do this work, or can we use the tables in NFPA 70E to define what the risk levels are? So the authors of 70E make it very clear that their intent was to encourage the use of the engineering analysis method over the table method, but they do allow for the use of these tables, but they set parameters that have to be met in order to use those tables. So in other words, the tables may only be used if the specific task being performed is listed in that table, and then the system meets or listed criteria for the short circuit current and speed of response of the circuit protection. So if that task does not appear in the table, or the fault current or circuit breaker clearing time do not meet the criteria listed, that table cannot be used for those activities, and you would have to have the engineering analysis take place. Another thing that's mentioned in the code more strongly now in 2015 is that the owner of the electrical equipment is definitely responsible for the accuracy of the labels. Sometimes people question, who's necessarily responsible, and it's important to understand that even if you have an outside contractor coming into your facility, you're the one responsible, and you have to have those labels on there. I'll oftentimes hear people say, well, our guys don't work on any of the equipment, we always bring in contractors. But it's still the responsibility of the owner to have those labels on those panels or disconnects or control panels so that anyone coming in understands what the risk levels are and can do their job in a safe way. So updating your arc flash safety training and retraining, having the assessment done is the first step towards compliance, but that's not all you have to do. You can put those labels on there, but if you haven't trained your guys to what that information means and what the risks are, then you're still left, you're still left in a way that you're not compliant. So code says that training must occur at a minimum of every 3 years. It also says that it must be documented and verified and inspected at least annually. So those annual inspections, basically what that is the employer is responsible to audit their guys, make sure that they're doing safe work practices, make sure that they're doing the lockout tagout, make sure that they're doing it correctly. And anytime something is noted that they're not, then you've got to address that. And as I stated earlier, when you're talking about training, participants must be able to demonstrate the knowledge. It's not just enough to sit in a classroom and have that information given to you, but you've got to go out and make sure that they're demonstrating that they know what they're doing. When you talk about qualified personnel, it gets a little tricky because the only person that can truly say if someone is qualified is the employer. There really isn't any official certification program for arc flash training, but code says you've got to have the training, so it's up to the employer to make sure that the appropriate training is given to their employees so that they can be considered qualified to do their job. As far as when should training be redone, as we just said on the last slide, code says you got to do it every 3 years, right? Well, in some cases that's not enough. One thing that people often don't realize is if there's tasks that are done very infrequently, something that's performed less than a 1 year interval, you need to be trained prior to doing that task each and every time. It doesn't apply to a lot of facility maintenance guys. A lot of guys do the same stuff day in and day out. But if there's ever a task that has more to it and something that isn't done very often, it's a good idea to do that training more frequently. Also, like I said before a little bit, the employer is supposed to go out and audit and make sure that people are doing what they're supposed to be doing, using annual inspections. So if someone comes across an employee who's not doing what they're supposed to be doing, then you've got to have that training redone. And as we all know, technology is constantly changing. So anytime a new technology comes out, or there's a change in a procedure, or if we go through your facility and launch new lockout tagout, as Andy said, it's important to make sure you sit down and talk to everyone and redo training at that time. As far as what should be included in the training, NFPA 70E has a very specific list of everything that should be in there. So I'm going to touch on some of them that are listed on the screen right here. Not everything is listed, but this is a good summary of what should be in there. Basically, what needs to happen is you got to make sure your guys understand the specific hazards associated with electrical energy. So what that looks like is you talk about the arc flash and arc blast risks, and you talk about shock hazard. Those are two very different things, but anytime you're working on live energy, those are both very dangerous things that you're dealing with. Also need to go over special precautionary techniques and safety-related work practices. What this is talking about is, lockout tagout. The arc flash training should include lockout tagout information, and also talking about a lot about the PPE. What PPE needs to be worn, how does it get worn, when do I know what PPE to put on? And that really goes back to the assessment and defining what that incident energy level is, or defining what the category is, and knowing how to relate that information to the PPE that needs to be worn. Code also says that anyone that's going to be involved in any type of emergency response needs to have that training as well as the AED training. So anyone that's going to be a qualified personnel for electricity work, it's a good idea to have them get the emergency response and AED training. And a big piece of that, although very simple, but very important, is that idea of contact release. If someone's being electrocuted, the last thing you want to do is grab onto them because you're going to become the second victim. It's also important to make sure your guys have the skills and techniques to distinguish energized parts and determine nominal voltage. So that starts getting into, how do I use a multimeter? How can I tell if something's energized? Most people already know how to do that, but it's a good thing to, talk about it and make sure everyone's on the same page. The approach distances are very important to include in the training. There's two different types of approach distances. There's that limited and restricted approach, which are specifically related to a shock hazard. And then there's that arc flash boundary that we talked about, the level or the distance at which the incident energy is 1.2 calories per centimeter squared. So the training should cover those and make sure guys understand, where you have to be standing to be safe, and make sure that they are safe, and make sure that everyone else in the area is safe. And then also, to kind of wrap things up, you talk about the decision-making process and the ability to perform job tasks. It's talking about energized work permits and the electrical safety program especially. Do those job briefings, have the planning checklist, the things that you do up front. Take a little bit of time to talk about the project and make sure that everyone's working safe. The whole idea is to make sure that we can all do our jobs on a daily basis, and at the end of the day we can go home and do whatever it is that we enjoy doing when we're not at work. So with that, I'll turn it back over to Graybar, and I think we're going to spend the rest of our time doing some Q&A.
Yes, that's right. Thank you, Josh and Andy. It was a great presentation. We're ready to start taking questions. So if you have a question, feel free to put it in the Q&A box down at the bottom. We already have some in the queue here. So I will get started. Here's the first one. When it comes to lockout, who is qualified to author lockout procedures? I believe that one's for Andy. Andy, you still out there? Might be on mute. All right, let's skip ahead. Maybe Andy will come back. Let's find one for Josh. What are common items in a facility that require an arc flash label but are not labeled?
Commonly, the most common one that I see are probably disconnect switches and control panels. Like I said, a lot of people, understand very clearly, hey, we got to put labels on our panel boards. And sometimes they'll skip that stuff that's downstream. And it's important because a lot of times I've seen studies, you can all go on YouTube and Google the videos and see arc flash explosions, but I've seen 30, 60 amp three-phase disconnect switches with very low incident levels, incident energy levels at like 0.5, And when you watch the videos of those, you see the explosion traveling outside the box, and you see the molten copper and shrapnel flying outwards. So even at that low level of incident energy on those very common pieces of equipment, there's still a lot of danger.
Okay, great. Here's another one. What is the most significant change to 2015 NFPA 70E standard?
I personally think the most significant change is really the PCE tables. You know, everyone used to reference the HRC categories, you know, the HRC tables, and they really revamped them a lot in 2015. And as I said during the presentation, they took those tables and they split it up into two different sets of tables. The first one is really task related. When you take a look at it, you read through and you see what those tasks are. And the tables now also identifying equipment conditions. So what the authors of the code were looking at there is, you know, if you're operating a circuit breaker or something like that, and everything's installed properly, maintained properly, doors are closed and secure, it's not an arc flash hazard. But, you know, that same type of equipment, if the equipment's not installed properly or there's something wrong with it, then even just operating a switch or a circuit breaker is considered a hazard. But then when you move on from those tasks, you then go to the second set of tables, and it outlines, you know, the different equipment types, parameters, and what those PPE categories are. So they made a lot of changes to those tables, and it's important for people to understand that.
Okay, perfect. Here's a question that says, these labels do not identify the distance. Didn't you say distance must be on the label?
If they're talking about the labels specifically that were shown in the presentation, that's a great catch. I like the slide that had the information. The two labels were on there were actually just generic labels. Okay. Generic labels, you'll see them out there everywhere. They're good to have on your equipment, but absolutely, the distances should be on those labels, and that's something that, you know, any good consultant's going to put on there.
Okay, perfect. Good catch. Why not label 4-square junction boxes or similar boxes?
4-square junction boxes, you know, typically aren't going to be something where you're going to be doing troubleshooting or any type of maintenance or work. When you talk about a 4-square junction box, that's something that, you know, is the installation of that is, you know, obviously done typically by an electrical contractor, and that's going to be driven by the National Electric Code. So when you're talking about maintenance standards in NFPA 70E, you're really talking about the abnormal conditions. So, you know, a junction box once installed, everything's closed up, it's good. The contractor did it correctly, a code inspector comes through, you know, it checks off on the facility, and the facility has occupancy and you can use it. But when you talk about actually maintaining things, you know, you're not going to go to a junction box and you're not going to typically do your troubleshooting there. Your troubleshooting is going to be at your disconnect switches, your panel boards, your control centers. You know, you've got to open those up, change a circuit breaker, change a fuse. If you've got a control panel on a, you know, assembly line or something, you got to do your troubleshooting, your testing for different voltages at that location. But, you know, the junction box should be secured, should be closed, and any time that you're going to be doing any work to that system, you should be shutting power off there.
Okay, here's a question from James. Did I understand you correctly that I should have a warning label on any equipment if there's 50 volts or more present? Yeah, so again, you know, people start saying, well, geez, that covers a lot of stuff. When you start getting down in the, you know, you might have a disconnect on something that's 120 single phase. Technically, according to the code, yes, that should have a warning label because it's greater than 50 volts, and there is an arc flash risk there, although it's very small. So what I always recommend to people is to, you know, focus on your larger stuff first, and usually where I recommend the cutoff is at the 3-phase, but even at that, so, you know, 208 volt 3-phase should have a warning label on it. In the past, you know, going back to NFPA 2009, there was an exception in there that said if something was connected to a transformer, a single transformer of size 125 kVA or smaller, that you didn't have to do the assessment, the engineered assessment on it and provide that label. That has since been removed. That exception is no longer in NFPA 70E, and that's something that was derived from IEEE 1584. But the intent there, you know, what they were basically saying is that at a smaller transformer, there's just not enough energy coming through it, you know, just based on the physics of the transformer to have a very substantial explosion. But, you know,
again, that exception has been removed from NFPA 70E because they realized that at a lot of those 208 and 240 volt, three-phase pieces of equipment, there is a substantial amount of energy there, and there's definitely enough energy for someone to be injured. So you have to put the label on there. And even if the incident energy is low and the explosion isn't that high, you still have the shock value. So you look at what's required on those labels. You've got to have the voltage class and the limited and restricted approach information provided on those labels, which is specifically rated to shock hazard.
Okay, here's a question. How can I get my company to abide by the new rules and implement some of these requirements? Is there any literature that I can pass on to upper management?
There's some white papers out there that talk about this information. So if you go on and Google NFPA 70E requirements, you'll get quite a bit of good information. But that's something. If we get the email address and name of that person, if you would please, and we can send them some information on some documentation that they could potentially give to management to help push that decision forward.
Okay, great. We will do that. I think Andy is back. So Andy, we've got a question for you. When it comes to lockout,
okay,
who is qualified to author lockout procedures?
So OSHA doesn't have a specific certification for who can author procedures, but they do ask that the person has an understanding of the operation of the equipment and the hazards associated with it. Specifically, manufacturing engineers are obviously because they put processes in place, but operators can write them, safety department can write them, but it's accuracy review to make sure that the energy sources are correct. You've got all the energy sources and someone who understands the operation of that machine.
Okay, great. And then we have got another one here for you. How can I get my employees involved in the procedure creation process?
So it's right at the start, make them a part of the process, especially the operators on the machine and the mechanics or the maintenance people that work on them. Specifically even the mechanics, because most often they're the authorized people. But the operator is important too because they understand the operation of the machine even better than the maintenance technicians. The maintenance technicians may know how it works, but they don't necessarily understand the day-to-day operations and shutting it down in a normal process in some cases. And then involve them through the process as you're writing the procedures, or if they're writing the procedures, involve them in the content and things like that because they're the ones that are going to be using them. And it's much easier to promote the use of them if they feel they have buy-in to those procedures as opposed to just having them forced on them, you have to follow this, and it's not in the mode that they would.
Okay, this one's going back to Josh. How does an electrical contractor approach a facility that has no arc flash analysis or labeling when performing electrical work?
The best thing that they can do at that point is then defer to the NFPA 70E PPE category methods. So those tables that we talked about that are in NFPA 70E, again, set a list of tasks and set a list of equipment and what that looks like. Although the contractor isn't going to necessarily know that the parameters are met, this table still gives a good guideline of what they should have on. So, for instance, the Table 130.7 talks about panel boards, rated greater than 240 volts or up to 600 volts. So talking about a very basic corner A-bolt panel. It says that is PPE category 2. In some cases, those panels could be greater. So if a contractor is concerned, that this doesn't make sense, the best thing to do would be to wear the category 4 suit or a 40 cal suit. But prior to that, the best thing to do would be to make sure power's shut off. If power's shut off, you don't need to have the PPE on because the risk isn't there.
Okay, this question's getting back to the 50 volt comment earlier. Does that mean that all 110 volt switches for fans, lights, etc. they need a warning label?
That's a great question. That's one I get up because people start getting scared when I mention 50 volts or above. The NFPA 70E, does allow for basically the qualified person to make a judgment on what the risk is. And when you start talking about stuff like 110 switches for fans and lights, those aren't items that are typically going to be worked on or serviced or adjusted. So when the code specifically talks about equipment labeling, they list those items and they say anything that's likely to require examination, adjustment, servicing, or maintenance while energized. So when you're talking about a 110 fan switch, that's something that really doesn't fall into that category.
Okay, we've got one here. Please discuss how OSHA enforcement relates to NFPA 70E.
So the OSHA enforcement as it relates to NFPA 70E, it happens in a lot of different ways. If you go on the OSHA website and just look up fines for electrical arc flash, you'll see a wide range of what potentially could get fined. So, stuff that I very commonly see, if people don't have the PPE, if they don't have the training, if they don't have, if an accident happens and they didn't have the labels, those are all things that OSHA will fine you for. So in a lot of cases, and this varies from, area to area depending on who the authority having jurisdiction is and what their interpretation or what their ruling is going to be. But a lot of times OSHA doesn't come out or people don't come out and say, you've got to have the labels. If you don't have them, they'll make note of it, but they're not going to fine you. But they do say you've got to make sure you're telling your employees what the risk levels are. So, how are you going to do that unless you put a label on there? So, they kind of dance back and forth a little bit, but at the end of the day, if you haven't done an assessment of some form, be it the incident energy analysis or the NFPA 70E table method, if you haven't done that, some sort of analysis and provided your employees or other contractors coming into your building to work on panels, if you haven't given them that information of, hey, what are the risk levels at this, at this piece of equipment, something happens, OSHA is going to fine you for not making them aware of what the dangers were.
Okay, thank you. Here's another one. Is there a recommended integration of JHA/JSA, energized work procedures, energized work permits, and arc flash distances and PPE ratings?
Say that again?
They're asking for a recommended integration of energized work procedures, energized work permits, and arc flash distances and PPE ratings. We can follow up after the call.
Sure. No, I would say, the best thing to do is have an overall electrical safety program that covers all of this stuff. NFPA 70E in the back in the annexes does have a recommendation for electrical safety program and, what all that should include. And that's going to include all those different items, overall to make sure that electrical safety is covered from all different avenues.
Okay, great. I think we got all the questions out there. So I wanted to show everybody this next slide. We're running a special promotion now, Graybar and Brady, and if you spend $500 or more on Brady Lockout Tagout products, you can receive this free duffel bag and 6 padlocks. So I just wanted to let everyone know about that out there, so you can talk to your Graybar rep about that. And also, if you're interested in getting an assessment of your lockout tagout procedures, definitely reach out to your Graybar sales rep, and they can bring in their Brady representative too to talk to you about that. So if there's not any more questions, I guess we're ready to wrap up. So I wanted to thank everybody for your time today. Thank you to Andy and Josh as well from Brady. As a reminder, this presentation will be archived on graybar.com, so you can see it again or share it with your coworkers. And once again, thank you for your time, and we hope to see you again on the next G2 Talk. Thanks again.